Alert! Huge asteroid 3 times the size of the UK will be so close to Earth that it will be visible with the naked eye. We're talking about asteroid Vesta, one of the largest asteroids found so far. Vesta is a minor planet designation for Vesta, and it's one of the largest objects in the asteroid belt, with a mean diameter of 326 miles or 525 kilometers. It was discovered by the German astronomer Heinrich Wilhelm Olbers, 29th of March, 1807. It's named after Vesta, the virgin goddess of home and hearth from Roman mythology. Vesta is the second most massive and second largest body in the asteroid belt after the dwarf planet Ceres. It contributes an estimated 9% of the mass of the total asteroid belt. 9%, let's say 10% of the asteroid belt mass. It's slightly larger than Pallas, though significantly more massive. Vesta is the only known remaining rocky protoplanet with a differentiated interior of the kind that formed the terrestrial planets. Numerous fragments of Vesta were ejected by collisions 1 and 2 billion years ago that left 2 enormous craters occupying much of Vesta's southern hemisphere. Debris from these events have fallen to Earth as Howardite, Eucrite, Diogenite, HED meteorites, which have been a rich source of information about Vesta. Vesta is the brightest asteroid visible from Earth. Its maximum distance from the Sun is slightly greater than the minimum distance of Ceres from the Sun, though its orbit lies entirely within that of Ceres. NASA's Dawn spacecraft entered orbit around Vesta 16th of July 2011 for a 1-year exploration and left orbit on the 5th of September a year later, 2012. En route to its final destination, Ceres. Researchers continue to examine data collected by Dawn for additional insights into the formation and history of Vesta. And this is it, Vesta on the left, Ceres and the Moon, with its sizes shown to scale. So you can see the difference in size. Now, Heinrich Olbers discovered Pallas in 1802, the year after he discovered Ceres, after the discovery of Ceres, and he proposed that the 2 objects were the remnants of a destroyed planet. He sent a letter with his proposal to the English astronomer William Herschel, suggesting that a search near the locations where the orbits of Ceres and Pallas intersected might reveal more fragments. These orbital intersections were located in the constellations of Cetus and Virgo. Olbers commenced his search in 1802, and on the 29th of March, 1807, that's when he discovered Vesta in the constellation Virgo. A coincidence, because Ceres, Pallas, and Vesta are not fragments of a larger body. Because the asteroid Juno had been discovered in 1804, this made Vesta a 4th object to be identified in the region that was known as the asteroid belt. The discovery was announced in a letter addressed to German astronomer Johann Schroeter, dated 31st of March, because Olbers already had credit for discovering a planet, Pallas. At the time, the asteroids were considered to be planets. He gave the honor of naming his new discovery to German mathematician Carl Friedrich Gauss, whose orbital calculations had enabled astronomers to confirm the existence of Ceres, the first asteroid who had competed the orbit of the new planet in the remarkably short time of 10 hours. And Gauss decided to name the new asteroid from the Roman virgin goddess of home and hearth, Vesta. Now, we will be able to see it with the naked eye. The colossal asteroid, more than 3 times the size of the UK, has come so close to Earth, it's now visible with the naked eye in the night sky in both the northern and the southern hemispheres. Matt Drake reports on Express UK. This asteroid measures more than 310 square miles in size, which is 50 times wider than the meteor that wiped out the dinosaurs. The asteroid, known as Vesta 4 or Vesta, is so big and bright it can be spotted despite it being 106 million miles away. It can be seen in the night sky close to Mars, Saturn, and Sagittarius constellation. Fortunately, NASA says the asteroid is not coming any closer to Earth, so there's no chance of it making impact with Earth, so there's nothing to worry about. It's just that we could enjoy viewing it, and I'm sure a lot of amateur astronomers will have their telescopes aimed at getting images and videos of this. It will be visible in the night sky until July 16. Vesta is named, as we said, after the goddess of hearth and household in Roman mythology. The asteroid is one of the largest known to mankind. It currently resides in the asteroid belt, and it will appear in the night sky as a dim yellow dot. This gargantuan asteroid will be easy to spot compared to other space rocks, as its surface reflects more light than the moon does. Stargazers in the northern hemisphere will spot Vesta beyond the northwest tip of the Sagittarius constellation. Now, people in the southern hemisphere will see the asteroid appearing southwesterly of the constellation. Asteroid Vesta was last visible in the night sky in 2011. As we said, Vesta is the second largest chunk of rock orbiting in the asteroid belt, with Ceres being larger. Ceres was recently reclassified as a dwarf planet. Saturn and Mars will also be nearby and will be visible with the naked eye from now until mid-July. So, yes, and as we said before, Vesta makes up about 9% of the total mass of the asteroid belt. Its size and unusually bright surface make Vesta the brightest asteroid, and it's occasionally visible to the naked eye from dark skies without light pollution. So in a clear sky, not close to the city lights, you can see it very easily. In May and June of 2007, Vesta reached a peak magnitude of 5.4, the brightest since 1989. At that time, opposition and perihelion were only a few weeks apart, and it will be brighter still starting June 22nd, 2018, up to July 16, as we said, reaching a magnitude of 5.3 luminosity. Less favorable oppositions during late autumn 2008 in the northern hemisphere still had Vesta at a magnitude from 6.7 to 7.3. So even when it conjuncted with the Sun, Vesta will have a magnitude of about 8.5 from the pollution-free sky, and it can be observed with binoculars, even at elongations much smaller than near opposition. Some small solar system bodies are suspected to be fragments of Vesta caused by impacts. The Vestian asteroids and HED meteorites are examples. The V-type asteroid 1929 Kola has been determined to have a composition akin to cumulate eucrite meteorites, indicating its deep origin within Vesta's crust. Vesta is currently one of the only 6 identified solar system bodies of which we have physical samples, coming from a number of meteorites suspected to be Vestan fragments. It's estimated that 1 out of the 16 meteors originated from Vesta. The other identified solar system samples are from Earth itself, meteorites from Mars, meteorites from the Moon, and samples returned from the Moon, the comet Wild 2, and the asteroid 25143 Itokawa. The geology of Vesta. There's a large collection of potential samples from Vesta accessible to scientists in the form of over 1,200 HED meteorites, that's Vestan achondrites, giving insight into Vesta's geologic history and structure. NASA Infrared Telescope Facility studies of asteroids suggest that it originated from deeper within Vesta than the HED meteorites. Vesta is thought to consist of a metallic iron-nickel core about 214 to 226 kilometers in diameter, an overlying rocky olivine mantle with a surface crust. And from the first appearance of the calcium aluminum-rich inclusions, the first solid matter in the solar system forming about 4.5 billion years ago, a likely timeline is as follows. Timeline of the evolution of Vesta. 2 to 3 million years ago, accretion was completed. 4 to 5 million years ago, complete or almost complete melting due to radioactivity decay of Al-26, leading to separation of the metal core. 6 to 7 million years ago, progressive crystallization of a convecting molten mantle. Convection stopped when about 80% of the material had crystallized. Extrusion of the remaining molten material to form the crust, either as basaltic lavas in progressive eruptions or possibly forming a short-lived magma ocean. The deeper layers of the crust crystallized to form plutonic rocks, whereas older basalts are metamorphosed due to the pressure of new surface layers, slow cooling of the interior. Vesta is the only known intact asteroid that has been resurfaced in this manner, and because of this, some scientists refer to Vesta as a protoplanet. However, the presence of iron meteorites and achondrite meteorite classes without identified parent bodies indicates that there once were other differentiated planetismals with igneous histories which have since been shattered by impacts. On the basis of size of V-type asteroids, thought to be pieces of Vesta's crust ejected during large impacts, and the depth of Res Sylvia crater, the crust is thought to be roughly 6 miles thick. Findings from the Dawn spacecraft have found evidence that the troughs that wrap around Vesta could be graben formed by impact-induced faulting, meaning that Vesta has more complex geology than other asteroids. Vesta could have been classified as a dwarf planet if it had retained a spherical shape, and has other qualities that lead to the thought it could be a protoplanet. The only thing that knocked it out of the category of a dwarf planet was the formation of 2 large impact basins at its southern pole. At the time of these impacts, Vesta was not warm and plastic enough to return to a shape in hydrostatic equilibrium.